We are going to work with scientific notation. We're going to rewrite this number, 60 million, as the product of two factors. What do you think of when you think of product? Yeah, we're going to multiply. We're going to multiply two factors of 60 million times each other. But the first factor is going to be a number that is greater than or equal to 1, but less than 10. We're looking for a number between 1 and 10. That's going to be our first number. And we're going to multiply it by a power of 10. Okay, so let's take a look at what this would become. What factor of 60 million? Think, what does it mean to be a factor?
You're able to multiply it.
So I can multiply a number by something and get 60 million. I could also describe a factor how else? What else does it mean to be a factor of? So what operation does factor sound like? Yeah, like you could also think about like what is something divisible? What number could I divide 60 million by? Like, is it divisible? What factor could I use for 60 million that's between 1 and 10? 6, absolutely. Think about what I can multiply 6 by to get 60 million. So I have this number 6 and I'm going to multiply it by a power of 10. What number would you multiply 6 by to get 60 million? 10 million. Yeah. Now, that's still not scientific notation because for those of you who have seen scientific notation, it's still not as simplified as it can be, right? How many times am I multiplying 10 by itself to get 10 million? So I have 10 times 10 is 100, times 10 is 1,000, times another 10,
10,000,
times another 10,
100,000,
times another 10,
1 something,
times another 10, 10 million. Yeah, so how many times here have I multiplied 10? 7 times. So I can rewrite this. I can rewrite this as with an exponent.
10 to the 7th.
10 to the 7th power. Absolutely. So here, when I put it all together, if I'm writing 60 million as the product of two factors, my first factor here, that number between 1 and 10, I determined was 6. And then the power of 10 was 10 to the 7th. How could I check that? How can I check it and make sure that really is 60 million?
You could break it out.
Yeah, I can actually break it out. I can multiply 6 times 10 times 10 times 10 times 10 times 10 times 10, and that would be 60 million. So how do I know how many tens to use when I'm writing 10 million? Like, how did I know that it was 10 to the 7th?
You divided 10,000.
All those zeros.
You divided 10. If you divided 10 million by 10, it wouldn't necessarily give you a 7.
Because every single time we multiply by 10, we added a 0.
All right, so every time we multiply by 10, we added a 0. And I hear a lot of you saying, like, well, I see that there's 7 zeros. Okay? Hold on to that thought. Okay, so I want you to think really hard about if the 7 is like the zeros. So this is what we're going to add in to our notebooks. To write a number, the bottom portion, I'll read the first portion to you. When you write 60 million as 6 times 10 to the 7th, you use scientific notation. You might have seen this. You probably have in science class already. Scientific notation is when we can use exponents to represent really big or really small numbers in an easier way. And like even 60 million is probably not that big. I'm talking trillions, like those types of numbers. Think about numbers that are super, 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 super small. Right? So to write a number using scientific notation, we write it as a product of two factors. The first factor, that first number, is always going to be a number between 1 and 10. In this example, it's a 6. The second factor is power of 10. And we know powers of 10 without the exponents could be 10, 100, 1,000, 10,000, anything that is 10 multiplied by itself over and over again. We can represent that as the base of 10 with an exponent. So if we, and you had already said it, if you wanted to prove that 6 times 10 to the 7th was 60 million, you could break it out. 10 to the 7th is 10 million, 10 million times 6 is 60 million. However you wanted to break it out would be sufficient. use the same idea for this number here. How would I write the number 1,850,000 in scientific notation? That first factor needs to be a number between 1 and 10. What factor of 1,850,000 is between 1 and 10? Why did Ibrahima say 1.85? He's correct. That does fit our criteria. It's a factor of 1,850,000, and it is between 1 and 10. Why didn't we just use the number 1?
It's not a factor of 1,000,000.
1 is not a factor
Not a
of
power of 10.
1 million. 1 is a factor
Well,
of
because-
1,850,000, but the other part of it is think about what you're going to multiply it by.
Yeah, that's how.
If I multiplied 1 by a power of 10, is there any way I can get 1,850,000?
No.
No, if the only thing you're doing is multiply by 10 or another 10 or another 10 or another 10, these numbers have to be represented somehow. So we have 1.85. Next question, what power of 10 am I multiplying by?
Yeah, 6.
Does everyone agree it's 6? Anyone want to tell me what the most common incorrect answer would be?
4.
4. Why do you think people might say
Because they count the
4? Because they count the zeros. So think back to the example that we used when we had 60 million. Yes, the exponent was a 7, but it wasn't because there were 7 zeros. What was the 7 representing? 7.
place value.
Yeah, it's place value. It represents our place value. So the power of 10 is equal to the number of place values that the digit increases. We do not count zeros, because if you do, you'd be incorrect here. You only would have counted 4. But think about what number we had. If we have 1,850,000, we're going to take the number 1.85 and we're going to multiply it by a power of 10 to get 1,850,000. What did I really multiply by? I multiplied by 10, another 10, another 10, another 10, another 10, another 10. How many 10s did I multiply by? 6. That's where we get that exponent of 6. So it is not counting zeros. It actually tells us how many place values our digit is increasing. So now we have a number in scientific notation. How would I write that in standard form? What do you think I mean by standard form?
Like regular.
Yeah, just broken out. Like that number, how do I write it? Large, not simplified in scientific notation. What do you think I need to do? Like, what am I actually going to do to take 3.54 times 10 to the 5th and write it in standard form? I'm actually going to multiply. Okay. And I'm going to multiply 3.54. How am I going to show multiplying by 10 5 times?
Moving your place value to the right.
Yeah, every time I multiply by 10, my place value shifts. What would go in all of these?
Zeros.
Yeah, zeros. So if I had to represent this number in standard form, we had 354,000. We're going to do a lot of practice with large numbers in scientific notation. Tomorrow we're going to spend time looking at really, really small numbers in scientific notation. So right now we're going to complete this table. We're going to take like 6 minutes. And I know we are running a little short on time. So I'm going to pause this. But we are going to fill in these. You have 5 numbers here. 3 of them are given to you in standard form. 2 of them are given in scientific notation. Fill in the other 5 blanks of the table.